Welcome to the very first lecture of our C programming series. Today we are going to see some basic terms which we already use in our day-to-day programming journey. So let's start with those terms and then we will proceed further. We will get to know about programming languages and then we will get to know about the C language. The very first term which we widely use is instruction. Instruction. Second one is program. Third one is software. Third one is software. So let's discuss one by one what is the difference between them. So first, the very first term is instruction. So what are instructions? Instructions are nothing but a set of lines of code. Instructions are nothing but set of lines of code, means whatever code you write, through code what you do, with the help of code you instruct your machine. So instructions are nothing but the set of lines of code, means when you will write multiple lines of code or a single line of code, then they become instructions. Means one line of code will be one instruction, two lines of code, three lines of code, and if you will combine them, they will be a block of instructions. They will become a block of instructions. So instructions are nothing but the lines of code which you write. Then comes the next thing, which is program. Now what is program? Program is nothing but a set of instructions. Set of instructions, which means when you will combine multiple instructions together, when you will combine multiple instructions together, that will be a program. And the third one is software. Software is nothing but a set of programs. A set of programs, or you can say that a collection of programs becomes a software. So if I will give you a real life example, with the help of two variables x and y, I want to do the sum of x plus y. So if I will write x plus y, so this is an instruction. This is an instruction. I am telling the machine to calculate the sum of x and y. Now, when we will combine multiple such instructions, for examples, I want to take input first, then after I want to do the sum, and then after print the sum on the console, print on console. So what are these? These are instructions. And when you are combining multiple instructions together, means you combine multiple instructions together, they became a program. And see, when you will combine such multiple programs, that will become a software. For example, calculator can have multiple programs, to add two numbers, to subtract two numbers, to multiply two numbers, and to divide two numbers. So when you will combine multiple programs together, that will become a software. So this is the basic difference. Once again, I am repeating, what are instructions? Instructions are nothing but the lines of code. For example, take input. See, this is not the actual code. I'm just giving you the overview right now. So code for taking input, then after code for doing the sum. So these are individual instructions. What are these? These are individual instructions, means this single line is a single instruction, this single line is a single instruction. And when you will combine such multiple instructions together, that will form a program. And when you will combine such programs together, that will form a software. For example, you are developing a calculator software which can do multiple programs, which can perform multiple operations. See, there is a program to add two numbers, there is a program to subtract two numbers, there is a program to multiply two numbers, there is a program to divide two numbers. So this is the basic difference between them. Next terminology is algorithm. What is an algorithm? All of you must have heard algorithms. So what are algorithms? So algorithms are nothing but a sequence of steps. Algorithms are nothing but a sequence of steps that gives method of solving a problem. Sequence of steps that gives method of solving a problem. Whenever we will reach to a problem statement, We will develop, we will write some steps, we will proceed to solve that particular problem step by step, and that particular step by step process is an algorithm. So algorithm is nothing, it is just a sequence of steps that gives method of solving a problem. Algorithm creates the logic of program. It creates the logic of the program. On the basis of this particular algorithm, whatever the algorithm you are developing, on the basis of this particular algorithm, program code is written. On the basis of this particular algorithm, program code is written. So I hope this is clear. Next term is programming languages. Now we will discuss what are programming languages. Before discussing programming language, I want to discuss what is a language. Some of you might know Hindi, some of you might know English. So if we are interacting right now, I am talking in English. So this is a medium of communication. And to communicate with each other, both the parties should know that particular language. For example, right now I am speaking in English. And if you know English, then you can understand whatever I am telling you, or then you can understand my language because you know English. Otherwise, if I know English and you know some other language, for example Hindi, Punjabi, then we can't interact, we can't communicate. So languages are nothing but a medium of communication. In the same way, computer understands a specific type of language. It can't understand human supported language. For example, right now English, if I will write any program in English, computer can't understand. So that's why languages, programming languages have been introduced. So programming languages are a medium of communication with the computer. So there are two types of programming languages. First one is low level language, and second one is high level language. Clear? Talking about the low level languages and high level languages. Low level languages are close to the machines and high level languages are close to humans. So let's discuss about low level and high level. It's very simple, very easy. See, low level languages are close to machines, and high level languages are close to humans. Low level languages are close to machines and high level languages are close to humans. Now see, it is very tough for humans to understand the language which is understood by the computer. For example, computer understands machine language, and machine language is nothing but the language written in binary bits, that is 0 and 1. For a human, it is very tough to understand everything in binary bits. That's why these languages have been introduced, so that humans can easily interact with the machine. Now, as we know, low level languages are close to machines and high level languages are close to humans. Means humans can easily understand high level languages. Why? Because it is close to humans, so it is more on human side. That's why it is easy to understand. And in the same way, low level languages are close to machines. That's why it is little hard to understand. I'm not saying that it is impossible to understand. Some human has developed this particular language, so it is not impossible to understand, but I'm talking about the convenience. High level languages are more convenient and low level languages are less convenient as compared to high level languages. What happens that whenever you write some lines of code in high level language or in low level languages, generally they are converted to machine language. So every language, the instructions which you write in any language gets converted to the machine language code, so that computer can understand that particular machine language. Now see, low level languages are close to machines, means there will be less conversion, so it will be fast as compared to high level languages. While high level languages are more close to humans, means they will have more English like alphabets, English like words, English like letters, so they will require a lot of conversions. That's why it will take more time to convert that particular language into machine language. That's why it is slow. It is slow as compared to low level language. Slow as compared to low level language means low level languages are fast in execution and high level languages are slow in execution. In the same way, if we will talk about more advantages and disadvantages, then see, low level languages are close to machines. That's why it is more error prone, means there are more chances of doing a particular error, or there are more chances of error. But in case of high level, this is close to human, that's why it is less error prone. I hope the differences are clear between high level and low level languages. See, this has been further classified into two parts. First one is machine language. And second one is assembly language. So we will discuss them one by one. In this category, the language in this category, in low level language category, is machine language and assembly language. So talking about the machine language, computer understands only digital signals, which are in binary digits, that is 0 and 1. So the instructions given to the computer can be only in binary codes, and computers can understand only these binary codes. That's why, see, machine language is very hard to understand and it is more favorable for our machines. So in machine language, instructions are there in binary bits. Binary bits means 0 and 1. So it is more favorable for computers. But for us, for human beings, a machine level language program is more error prone and its maintenance is very difficult. Just imagine you are writing everything in 0 and 1. Just imagine, for example, I will give you a program to add two numbers and you are writing everything in 0 and 1s. Don't you think that will be more error prone and maintaining that code is very, very difficult? So this is more error prone and maintenance is difficult, and maintenance is very difficult. I hope this is clear to everyone. Clear? We have machine languages, but there are some drawbacks. For example, this is more error prone, maintenance is very difficult. That's why assembly language came into picture. See, what were the difficulties in machine language? Assembly language reduced that difficulties to some extent. So in layman terms, you can say that assembly language is a modified form of machine level language. You can say that assembly language is a modified form of machine level language. In assembly language, instructions are given in English like words, such as if we want to add two numbers, we were using add symbol. If we want to subtract two numbers, we were using subtract symbol. So see, it is more easier as compared to machine level languages. A computer can understand only a machine level language. But right now we are talking about assembly language, and in assembly language we are using English like words such as add, subtract, move. For a computer to understand this assembly language, this must be translated to this machine language. Why? Because computer can understand only a machine level language. So this assembly language needs to be translated into machine language. So who will do the translation? Assembler will do the translation. So assembly language is converted to machine language with the help of assembler. Don't worry, we will discuss about the assembler, compiler, interpreter in the upcoming video. Now see, we know that writing programs in assembly language is little bit easier, but still a programmer has to know all the low level details with the hardware of a computer. Since low level languages are related with hardware, hence the execution of a low level program is faster. One thing which I want to discuss is machine language. See, every machine language has its own instructions, means binary bits, means its own signals, binary signals. So every machine has its own binary signals. That's why this language is not portable. Portable means program written on one machine can be executed on other machine. So machine language was not portable. Now talking about the assembly language. Assembly language was using English like words, so it is more easier to write, but it is close to hardware. Data is stored in computer registers and each computer has a different set of registers. Hence assembly language is also not portable. See, this is close to hardwares and every data is stored in registers. Data is stored in registers, and every computer has a different set of registers. So this was close to hardware. That's why this is not portable. That's why high level languages came into picture. High level language was designed keeping in mind the feature of portability, means these languages are machine independent, means program written on one machine can be executed on other machine. High level languages are designed by keeping in mind the feature of portability. Portability means machine independent. Means the code written on one machine can be executed on another machine. And these are high level languages, so they are English like languages. That's why it is easy to write, easy to understand. Programming in high level languages, programmer is not concerned about the low level details. For example, in assembly language, the programmer was concerned about the low level details. But in this case, programmer is not concerned about the low level details. Programmer is just concerned on that particular programming languages. So whole attention can be paid to the logic of problem being solved. In this case, we are not thinking about the low level details of the computer, thinking about the hardware of computer. We are not thinking about the hardwares of the computer. We are just focusing our mind on that particular problem which we are solving. So whole attention can be paid on that particular problem, not on the computer hardware. Clear? That's why it is easy to understand, easy to maintain. Computer cannot understand a high level language also. To convert a high level language into a machine level language, a compiler or a interpreter is needed. Don't worry about the compiler and interpreter. We will discuss about compilers, interpreters and assembler in the next video. Thank you so much. Thanks for watching this video. Have a great day. Bye bye.